So for the next section, it says to find the slope for the following points. So we have 2 points, so I'm going to label those x1, y1, and x2, y2. And you also need a formula. So I like to write the formula out. And if you do this while you're doing your homework or reviewing on each problem, then hopefully by the end you will have memorized it. Okay, so we have y2 minus y1. Who is my y2 here? Well, it looks like the y2 is 1. Minus because there's a minus in the formula in red. And then y1, which happens to be negative 3. So the negative in red is because of the negative in the formula. The negative in blue is because there's a negative on the 3. Okay, just want to make sure you understand that. On the bottom we have x2, which happens to be negative 1. Minus, because there's a minus in the formula, x1, which happens to be 9. Minus and negative, we don't do that, so that's really plus a positive. One way you can think about that is add a line and change the sign, so it's positive, and that gets you 4 on top. In the bottom, I have negative 1 minus 9. Both are the same sign, so you add their values, get 10, and keep their sign, which is negative. And then the last thing is 4/10 can reduce by 2. So if you divide the top by 2, you get 2. Divide the bottom by 2, you get negative 5. So m is equal to negative 2/5. The negative can technically go in the top or the bottom or out in front. As long as you only have one negative, I don't really care where the negative goes. Let's practice this again. We have x1, y1, x2, y2 again. I'm going to write the formula out one more time. y2 minus y1 over x2 minus x1. So the y2 in this case is negative 13. Minus, because there's a minus in the formula, y1, which in this case happens to be positive 2. On the bottom I have x2, which happens to be 9, minus in red, because there's a minus in the formula, x1, which happens to be 4. In this case, you just subtract the tops. That's negative 15, because they're the same sign, you add and keep their sign. 9 minus 4, because they're opposite signs, you subtract and take the bigger guy's sign, which is positive. So m equals negative 15 over 5, which reduces to negative 3. For the next section, it says to graph the following lines, find the slope and the y-intercept, and slope-intercept form of the line. So this one happens to already be in slope-intercept form. Slope-intercept form is mx plus b. So because it's already in the form, I can see that the m is negative 3/5. I can see that b is 2. So those are the only information you have to show on that side. Now I'm going to take these two pieces of information and graph them. So I'm going to go to 2 on my y-intercept, and then my slope of negative 3/5 says down 3, 1, 2, 3, and right 1, 2, 3, 4, 5. So I'm going negative 3 over 5. So I'm rising negative 3, so that means go down, and I'm running 5, which is 5 to the right. You could also put the negative on the bottom, so you could also rise positive 3 and run a negative 5. So going back to 2, if I rise 1, 2, 3, and then go negative 5 run, so that's then 2, 3, 4, 5 to the left, I still get another point on the line, and I get a nice beautiful straight line. For the next problem, we don't have it in slope-intercept form as it is, so we're going to need to do a little bit of work over here. So I'm just going to rewrite this. And then I want to remind you that in order to get it in slope-intercept form, I want y all by itself. Okay? So I circled the y to remind me that's what I want. So who needs to go? Well, it looks like the 2x needs to go. One way of doing this is subtracting 2x from both sides. Another way people like to do it is just to pick the negative 2 up, the 2x up. If you put it on the other side of the equal sign, it becomes negative. It changes sign. So if you just pick it up and move it to the other side, it just has to change to a negative. I like that method. But either way, you're going to get the same answer in 2 steps. Okay, so I divide each one by negative 3. And now that gets me y is equal to negative divided by negative is positive 2/3 x. Positive 12 divided by negative 3 is negative 4. So we have 2/3 x minus 4. So my slope is 2/3. My y-intercept is -4. So that tells me to go down to 4. I'm going to rise 2 and run 3. I have a lot more room here, so I'm going to just keep going, rise 2 and run 3. Or I could go down 2 and left 3. And that gets me a very nice straight line. For this next problem, it's very similar to the last one. I want to get y all by itself. It's right here. So I need to move the 5x. If you want to use transposition, if you pick the 5x up and move it to the opposite side, it just becomes its opposite, which in this case is -5x. The 4y stays the same, and the 20 stays the same because they didn't move sides. Now, if you're like, what in the world is she doing? This is so crazy. You could just go back to the same method we used before and just subtract 5x from both sides, and you still get the same thing that we just got there. I just think transposition is a little bit faster, just a little shortcut. So if you like it, go ahead and use it. Next, I want to get y all by itself, so I need to divide everything by 4, which gives me y by itself, because the 4's divide out, equals -5/4 x minus 20 divided by 4 is 5. So that is my equation, -5/4 x minus 5, which tells me that my slope is -5/4 and my y-intercept is -5. So I can go to -5 on my y-axis. Then I can go down 1, 2, oh, it's off my picture, 3, 4, 5, and over 1, 2, 3, 4, which is like way down here, which is way off my picture. Okay, so that's not really all that helpful. So what I could do instead of rising -5 and running +4 is I could rise a +5, 1, 2, 3, 4, +5, and then run a -4, 1, 2, 3, 4 to the left. Either way, you're going to get a straight line here. And if you don't want to include the one way off your graph, I totally understand that. I wouldn't probably do that myself, but just I wanted to make sure everyone could see why you're going either down and to the right or up and to the left, and they still get the same, they still land on the same line. These next two are special cases. So because there's only one letter and not two, this is a special case. So the first one is a HOI special case, and the next one is a VUX special case. HOI stands for horizontal lines have zero slopes and their equations look like y equals a number. So clearly that's y equals some number. So I know I have a horizontal line at 1, 2, 3, -4. So I can either just draw that first, that's really simple, or you could think about your slope first. This tells you right here we have a 0 slope. That's what the O stands for. It's also a 0, right? So my slope is 0. Where does it cross the y-axis? -4. So either you can get the m and b first here, or you can graph first here. Either way, it's going to get you the answer. Now this next one is a VUX special case because it only has an x value. VUX stands for vertical lines have undefined slopes. So right now I can come over here and put undefined for the slope. And the equations look like x equals some number. So because this is x equals a number, it's a VUX problem. So I can go to the x-axis, go to number 5, +5, and just go ahead and draw a vertical line, and that's getting me my answer. Where does my vertical line touch the y-axis? Because that's what b is. B is a y-intercept. Well, it doesn't. Here's a key. If your m is undefined, then your b is probably going to be none.